So after having used that combined gas law and watching that super long video, 17 plus minutes, there's that many slides to get through. I just have one example problem with using the ideal gas law as is. And this is the example problem. And so what we're going to do is look at PV equals nRT for these questions, and we'll see how we can calculate something. So one of the nice things about these types of problems is they will always have all of the variables in this. Of course, R is not a variable, so you won't see that in these problems, but they'll have a pressure, volume, number of moles, and temperature -1. It will not give one of these four things, these things right here. And so most of the problems, you're just identifying which one you're going to solve this equation for, and then do a calculation, plugging in the values in the right units. And many times it will not have all of the units in the correct units initially. So what units do you use? Well, remember that I said that one of the versions of the ideal gas equation was the 0.08206. This was a value saw on the previous video. This value has units of liters, atmospheres per mole, and Kelvin. And so we have all of these units here. So guess what? If you're using these units in your ideal gas constant, those are the units you have to use for your variables in the rest of the equation. So if we're looking at this reaction, calcium carbonate decomposes upon heating to give calcium monoxide. Well, that's just calcium oxide because that's ionic, right? And CO2 or carbon dioxide. A sample of calcium carbonate is decomposed and the carbon dioxide is collected in a 250 milliliter flask. After the decomposition is complete, the gas has a pressure of 1.3 atmospheres at a temperature of 31 degrees Celsius. How many moles of gas were generated? So let's look at this. So we already have our pressure in units of atmospheres. We have our volume, wrong units, so it needs to convert to units of liter conversion. And then we have, I know that doesn't look like conversion, squint, it'll look like that. And then we got temperature right here, so we have to convert to Kelvin. Okay, so this one is one that hopefully you practiced on the previous example. So we're looking at these things, and then we're going to have to convert this. Of course, to convert the 31 to Kelvin, we add 273. And this will give us, what is that, 294 Kelvin. If we're converting this to units of liters, I'm going to do that without showing a conversion factor, which is 2.250 liters. And then, actually, we only have two sig figs here, so let me underline that. And then if we're looking at this other things, atmosphere is already in the right unit, right? And so how many moles of CO2 were generated? Well, notice we're going to isolate this. So we got to isolate N. So N will be equal to PV over RT. And now all we have to do is plug in the units. We got 1.3 ATM. Then we got the 0.25 liters. And then we've got the, what is the other thing? Ideal gas constant, 0.8206 liters atmospheres per mole Kelvin. I should have put that in a fraction, just make it a complex fraction. But then we got the temperature, put 294 Kelvin. Now let's look at our units before we do any calculations. So notice we got Kelvin here and Kelvin there. But we have this slash here. So that means that this Kelvin could have been put in a complex fraction with the U down here, or it could have actually just moved up there. So this Kelvin cancels with that. Then we have units of moles in the denominator of a denominator. So actually moles goes up here. Then we have these liters cancel with those liters, and this atmosphere cancel with that atmosphere. And so we'll be in the end in units of moles, which is what we want. And so after that, we just grab our calculators and plug in the numbers. Multiply, I'd suggest starting with the numerator. Just multiply everything on the top and divide by everything on the bottom. Divide by 294. And then we get a number of moles equal to 0.0135. Oh, wait, 2 sig figs. And actually, this would just be 0.013 moles of CO2 was generated during that process. So, this point, go ahead and go back to Chem 101, do that second set of problems. Remember that you're going to be using the ideal gas equation or discussing things about the ideal gas equation in those problems. So, combined gas law, ideal gas equation, both very, very useful equations.